Let us solve another example. When we have x cubed plus y cubed all over x squared minus y squared times x squared plus xy minus 2y squared all over x squared minus xy plus y squared. So factoring the sum of two cubes, we will have x plus y times the square of the first term times last term times negative is negative xy. The square of the last term is positive y squared. And then factoring the difference of two squares, it will be x plus y and x minus y. Now, multiplied by the factors of the numerator, x squared will be x and x. Factors of negative 2y squared is negative. One is positive, the other is negative. But the positive must be greater than the negative, so it will be 2y and then y. So 2 is greater than 1. If we're going to check x times x squared, x times negative y is negative xy. 2y times x is 2xy plus a negative xy is positive xy. 2y times negative y is negative y squared. Now we're going to factor the denominator if possible. So the factors of x squared are x and then x. Y is only y and then y. This is negative, so both of them should be negative. Now let us check if the factors are correct. X times x is x squared. X times negative y is negative xy. Negative y times x is negative xy. Plus a negative xy is negative 2xy, which is not a negative 2xy, so my factors are wrong. There's no other factor for that, so therefore I can say that this is not factorable. X squared minus xy plus y squared. Now we look for the common factor between the numerator and the denominator and then divide out. X plus y, divide out. X squared minus xy plus y squared. X squared minus xy plus y squared. X plus 2y, there's no x plus 2y. X minus y, x minus y. What remains is just x plus 2y.